Hey, what's up guys? Welcome back to another video. This time we're going to be talking about the OpenAI Evaluations Framework. Evaluations, or evals, is a framework for testing the performance of large language models that you use in your software. So what I mean by that is OpenAI provides all these models that we can use through their APIs, such as GPT-5 at the time of recording, GPT-4, 4.1, 4.0, O3, O4 mini, all these kinds of models, right? So you can use them in your software. You just take the model, give it a prompt, send it a message, and then you get a response back. But how do you measure the performance of such a model? How can you systematically determine if it's working well or not? Evaluations is a way to figure that out. As another example here, what if you have GPT-5 and you hit it with two different prompts? Because the quality of a prompt that you give a large language model actually affects the performance, right? It tells the model what to do and how to act. So depending on what prompt you give it, it gives different results. So if you were to hit the same model with two different prompts, how can you empirically see which one is better? This is again where evals comes into play, because these models, right, we're not training them ourselves. If you've ever done machine learning, after you train your model, you then test it on a test set, and then that tells you stuff like the F1 score, the accuracy, the precision, the recall, all those different metrics that you would want to track, right? But for a black box like this that we're just using on our data that it's never seen before, potentially, it doesn't, obviously we just don't know the metrics of that. So that's what we're going to be using to test, okay? So evals is a good way to test different prompts with the same model, or it's also useful if you want to test different models. What if you're trying to do something like summarization or classification, but different models are going to have different, capabilities, right? So you want to test the difference between GPT-5 and then GPT-03, for example, right? So the way it works is when you're doing evaluations with OpenAI, you want to first come up with the eval set, or just a test set, basically the data that you're going to run the model on to determine if it's accurate or not. So if we just pretend that we have some software and we're trying to do some sentiment analysis, which is the task of taking a piece of text and classifying it as positive, negative, or also neutral. That is the task that we're trying to do. So we're going to use the OpenAI model, as I showed you here, give it a prompt, and then use it to get a response for each of the pieces of text that we feed to it, right? So here's an example of a data set, an eval set that we can build for that. The first column is just the text that we're going to be feeding the model. So I absolutely love this phone. The battery lasts all day. So obviously that's positive. So the second column is the expected label that we expect the model to produce when we invoke it. So when we are running an evaluation through OpenAI, we're going to feed it each row of text one by one. It's not going to see the correct label, obviously, that'd be cheating. We feed it one by one, we get the actual output from the model, and then we compare it to what it should be. And that way we're able to see how the model performs. So we're going to see this actually in action in just a second here, but this is a screenshot of what it would look like. So if I run GPT 3.5 Turbo on this eval set, we can see that for every text that we gave it, it produced an output of this. So you can see that for the first one, the correct output was neutral, but it said negative, so it's a fail. So we have the input here, the expected output, and what the output actually was. And then the last column here, this is just showing the grader that we're using. So for this particular problem, we're just checking to see, based on a string comparison here, we're checking to see if the output is the same string as the expected output. That's very simple. So we're using the string check grader. So it's just a pass or fail. But OpenAI provides a tons of graders that we can use. You can write custom Python code that does the scoring in a custom way. You can also have a model that does the grading. So you're using the evaluation on a model, and then a separate grader model does the evaluation and gives it a score. All kinds of stuff that I'll be showing you in just a second, but this is the most basic one that you can do. Just check to see if the output matches the expected output. So we're about to dive into actually how to use evaluations, of course. There's actually two ways to do it. The first option is to just do it on their website, which is really cool. You can create evaluations, do runs on them, and you get stuff that looks like this. The second way is programmatically, so they expose an API. Just like there's an API for the model itself, there's an API for running evaluations. So if you want to control evaluations programmatically, like maybe introduce them into your DevOps process, or just put it into your software, you can do that. You have full control over the evaluations process through code. So in this episode, in this video, I'll be showing you guys both approaches. We'll start with the platform website approach, and then we'll be jumping to the code to see how we can run evaluations through code. And we're going to be doing two examples. We're going to be doing first this example here, sentiment analysis is the most basic thing that we can do. And then when we do it programmatically, I'll be showing you guys how to evaluate a model that does multiple choice questions, okay? So I really hope this all makes sense so far. Let's jump into it. Okay, first I want to head here to the OpenAI documentation. I have a link for this in the description below. And what we want to do is scroll all the way down to evals. I just want to show you guys that this is actually a thing, because reading the documentation that they provide is actually very helpful. I highly recommend you read through this stuff, especially the second document here on eval design. This explains what evals are, what they're for, best practices, anti-patterns, really good stuff. Just focusing on this real quick, they give you a nice workflow for using evals in your software. So the first thing is defining the objective. So for our particular first example, we're trying to do sentiment analysis. So we're trying to take a piece of text and classify it as positive, negative, or neutral. And what we're trying to do with the evaluation is find the best model and the best prompt to be able to do sentiment analysis effectively. So after you have determined your objective, you then want to collect a data set, which is the eval set, right? The test set. So this will be the data that represents what the model will be seeing in production, what the model is actually going to use on. So you want data that represents what the model will actually see, because if you're evaluating the model on data that's different from what it will actually see in production, your evaluation metrics are not going to be realistic, right? So collect a bunch of data like I told you, and then that's what we're going to be using to run the model on to see how it does. So after that, you're then going to define your eval metrics. So like I said before, for this particular problem, it's just going to be a string check. Is the output the same as the expected output? If it is, then it passes. If not, it fails. So you can do that, or you can have other advanced metrics for different problems. And then after that, you run the evaluation. You run it, you make changes on the prompt or the model, you run it again, you see if it increased in performance or decreased, and then you can, you can keep changing things until you get a better and better model over time potentially. And then this last one here is a bonus. This is continuous evaluation. So if you have a DevOps process or anything like that, if you have an actual production application, you may want to do this where it says set up continuous evaluation to run evals on every change, monitor your app to identify new cases of non-determinism, and grow the eval set over time. So basically just setting up a process programmatically to continually improve the model's evaluations by finding edge cases that you add to the eval set, and also anytime you change anything with the model, you reevaluate it because you want to see how the performance changes, okay? So the first 4 points are the most important that we're going to be focusing on, all right? So they also give these two examples here. So here's an example for summarizing transcripts and QA over docs. So for example, just running through this real quick, if you're trying to summarize transcripts, that's the objective. You're trying to take a piece of text and summarize it while keeping relevance and accuracy. You're then going to collect a data set that represents what the model will be doing. So you want to collect a data set of chunks of text and then what the summarization of that would be. And then you're going to run the model on the chunks of text and compare the output of the model to what the reference summary is in the eval set. So obviously for this particular problem, this is a more open-ended generative problem where it's just summarizing a piece of text. With generative problems like this, it's not going to be very deterministic. You're not going to get the same output every time. So instead of just checking to see if the output of the model exactly matches the string of the expected output, you can check other metrics like the Rouge score. It's basically a metric that checks how close a piece of text is to another piece of text, which is good for summarization types of models, okay? So that's the eval metric in this case. So again, it depends case to case, all right? So I really hope that makes sense at a high level. Now let's go ahead and actually jump into creating our own evaluations and running them for the first time. We're going to see how to do it through the UI, like I said, and then later in the video, we're going to see how we can do it programmatically. So yeah, hopefully you're excited. Let's get started. Alright guys, first things first, go to platform.openai.com, then go ahead and log in, make sure you have a billing account set up, so add a credit card, add a few dollars. You really don't need more than that for some basic evaluations. And you need money, of course, because we're going to be running models to do the evaluations on, okay? So set that up, then you'll be good to go. So go to the dashboard, and then on the dashboard, you can then go to evaluations. So now here, this is where you can view all of your evaluations, and we can go ahead and create a new one. So the first thing that you do when you set up an evaluation is define the data of the evaluation, which is in other words just the test set that you're going to use for the evaluation. So there's a bunch of different sources you can use, which is really cool. One of them is import logs, so you can use stored completions, which is a cool feature they have where every time you invoke ChatGPT, you can store it, so it stores it in their system, and then you can use it later on for fine tuning or evaluations. You can create new data on the fly, so you can click this and just go through the process of manually adding rows. Here you got the most popular option, uploading a file, and you can upload a JSON, L, or a CSV file. And if you've done machine learning before or anything with machine learning, you're probably familiar with these, but CSV is just a comma separated values file. In other words, it's basically just an Excel file, but in a more universal format. It's literally just rows of comma separated values. That's where the name comes from. And then JSON L is a more specialized format of JSON files. But then other than that, you have some other options here. So I'm going to go ahead and click upload a file, and here you can select a file that you've uploaded previously, or you can just upload one on the fly. I've already got a JSON-L file here, so I'm going to select it. And so every row of this JSON-L file is an object that has a text field, in a correct label field. If you upload a CSV file, it should be very similar. It should recognize, if it's formatted correctly, the rows of the dataset, okay? This basic dataset here is just a sentiment analysis dataset. So basically taking a piece of text and identifying its sentiment as positive, negative, or neutral. It's one of the most basic machine learning tasks that you can do. So we're going to see how the different GPTs does on it as our first evaluation, okay? So we're going to evaluate it on GPT-5, GPT 4.1, and whatever model that we want to try on it, okay? So it's made up of two columns here. We have the text column, which is just the actual text that we're going to be classifying. So this is what we would want to feed to the model. So you can have as many columns as you want, but you can then do whatever you want with whatever column that you want. So this particular column, like I said, will be what we're feeding to the model. And then we have the correct label column, which is essentially what we expect the model to output. So we're not going to tell the model, obviously, what it should output. We're going to, invoke the model, give it the text, and then give it a prompt as well and see what it gives us. And then hopefully we'll check to see if it's positive for this first one here at least, okay? That's the basic idea behind evaluations. You upload some data. This is a very simple data set, but you feed the data to the model in some way. And then after that, you can use the other data of the data set to evaluate the model as well. So as long as the file here is showing correctly with a bunch of rows and data, you should be good. That means the format of the file is recognized and we can use it. One thing that you want to do is make sure you click generate new responses. So we're going to be invoking the model, like I said, and then using its response and checking to see if it's correct or not. So checking this will make sure that we're able to use the data responded by the model, okay? So make sure you check that. And then now everything else you can pretty much just leave it as it is. We don't need to do any images or anything like that. So click next now. So now that we have defined the data that the evaluation will be based on, we're going to now define how we're going to run the evaluation, which in OpenAI is called a run. In other words, what we're going to be doing is telling OpenAI through this platform here how we're going to invoke the model. We're going to give it a system or developer prompt, so just the prompt of the model, and then we're going to feed the data, like I said, to the model, and we're just going to tell also then how to evaluate it. Now, what goes here in this developer or system message is actually pretty important. This is, again, telling the model how it should behave, what it should do. And so it depends really on the task that you're trying to do with this evaluation. Are you trying to evaluate the best prompt for the task that you're trying to do? Or are you trying to evaluate the best model for the task that you're trying to do and you already have a prompt? So as an example, if you have a system that already uses GPT from OpenAI, and you already have a prompt that tells it what to do, it takes in a piece of text and classifies it, right? Since you already have that all set up, you want to copy that prompt from your software and put it here, because for this evaluation to actually be accurate and useful, you want to evaluate the model using the same prompt that it'll actually be using in your system, right? Because then you can get an accurate reading of how your model performs on this test set here, this evaluation set. So if that's what you're trying to do is find the best model, then take the prompt that you already have and put it here. If what you're trying to do is just find the best prompt overall, and that's why you want to do evaluations, then just put your best shot, put your best prompt inside of here. We're going to run the evaluation, and then you can modify the prompt and try it again. You can keep running it on different prompts to see how it compares. So that's another reason you may want to use an evaluation. So I'm going to simply say you are a classification bot. Your job, given a piece of text, is to classify it as positive. I have to spell positive correctly, negative, or neutral. Respond only with one of those labels because we don't want it to say other stuff like an explanation or something like that. We just want the label itself. And so that's the label that we're going to then compare to the correct label that we have in our evaluation set. If we want to, now we can take this text and put it into the prompt directly. But a more common way that you'll see it is in the user message. So this is essentially simulating us sending a message to the GPT, and it will respond with an assistant message. So what we're going to see in this user message is classify this text. And now we want to put a variable, so curly bracket, curly bracket. And what's really cool here is you can see it's already suggesting stuff from your data set that you uploaded. So we can do item.text. And so now when we're actually running our evaluations, it's going to send each of these samples here in each row to the model with this prompt and then this message with obviously the correct text injected in place of that variable. So really cool, right? Hopefully now you can actually see what's going on. We're defining how we're invoking the model, okay? So like I said, the model will respond with a assistant message, but we don't want to add that. That's what we're going to be checking. So after that, you can then choose the model. So you have all the models here offered by OpenAI. It's a lot, as you can see. At the time of recording, GPT-5 is the latest and greatest, so select that one. You can then select the response format. You can do like structured outputs if you want to, but I'm going to just do text. And then the reasoning effort, since we're using GPT-5, I'll just leave it on the default of medium. And then if you want to, you can also do tools for advanced features, but I don't really care about that. if you want to, it's there. So now we're done defining how the model will be invoked. So click next. So now this is the part where we set up the test criteria, which is taking the output of the model and determining how we're going to score it. Is it a pass? Is it a fail? Give it a score, stuff like that. So let's click add. And there's a lot of options here. So the first basic one that we can use that I told you about before is a string check. Check for exact or partial matches against a reference value. This is what we want to use in this case because we're checking to see if the output matches the correct label. So we have two inputs here that represent the two strings that we're trying to check for. And by default, we're trying to check equals, but you can also change it to does not equal, contains, or contains ignore case. You have a lot of flexibility, which is nice. And you can put anything inside of here, any string that you want. You could put like true if you want to, but we don't want to hard code in our case because the label will change per sample. So we're going to use variables. So to use a variable, you do double curly bracket, any of these options here again. So in this case, what we want to do is match the correct label in the first one to the output label. So the output label will be here, output from model, and we have sample, output text, output JSON, and output tools. We want output text. Okay, let's save it. So now that we've added the test criteria here, when we run the model evaluation on each of these rows here, one by one it's going to check what we just set up. So is the correct label equal to the output label? Okay, that's simply it. And we can add as many as you want. You can add multiple. So another one is text similarity. This is useful for things like summarization. So it says evaluates how closely input text matches a reference value using similarity metrics like fuzzy match, blue, rouge, or cosine similarity. These are just metrics in machine learning that, like it says, just checks how close two pieces of text are. So if we're trying to do summarization, usually have rouge. If you're trying to do translation, I believe it's blue, if I remember correctly. But yeah, just like before, you can provide the output and the expected output, and then you're going to choose what metric you're looking for. So you have all these options here. We can do the rouge L score, and then based on the score that's computed from these two variables here, you're going to get a number 0 to 1. So this slider here sets up the threshold for what becomes passing or not. So for example, if you're trying to evaluate summarization, you can choose Rouge L, and then you can scale this up if you want to only accept as passing Rouge L scores equal to 80 or above 80%, okay? So that's how you can set that up. Hopefully that makes sense. You can also do model labelers and model scorers. So for example, model scorer uses your custom prompt to instruct a model to evaluate outputs and assign numeric scores. So this is really cool. If you don't have a like a calculation that you can do and you want a model to do the evaluation, the grading, you can do that. So you can set up these presets here, which is pretty cool. But basically, you choose a model, give it a name, give it a prompt, and the prompt tells the model how to do the grading. Then you give the user message. So this is you giving the output and the expected output to the model. And then the model, depending on the prompt that you give it, we're telling in this case to do it in a range of 1 to 7. So the output of this should be a number 1 to 7. So then you can set the pass threshold for that as well. So very similar to the last one, except that the number outputted by this is given by a large language model. Okay, so that's pretty cool. You can use a model to grade a model. And then you also have Python grader. This one's very cool as well. If none of these give you what you want, if these built-in metrics or string checks are not what you're looking for to do your evaluation, you can just have a custom Python script that does the grading. So it's just so flexible. That's so cool, right? So this one returns, it looks like a number from 0 to 1 as a float. So you can then also customize the pass threshold based on that. So very, very cool stuff. So we've already got the string check grader that we want. And so once you have your test criteria set up, you can then click next. And now we're ready to actually run our evaluation. So what this will do when we click run is create the evaluation and then do a run based on it, which means that we're going to take the model, take the prompt, give it the eval set, and then run it. And then based on that run, we'll get some output and get some metrics, okay? So let me fix the name of our evaluation. I think I got reset. There we go. So sentiment analysis eval, running it on this input data, this model that we've already set up. What's really cool is that later when we do it programmatically, we'll have to do everything with, Python. So we can actually use this later on, which is really cool. It gives it to us directly. But yeah, looks good overall. Let's go ahead and run it. Boom. Okay, here we go. So you can see it's queued. It should start running in a second. But yeah, this is our eval. This is a particular run of the eval, so we can do more runs after it with different models and different prompts, different data as well. But usually the idea is you keep the data the same, generally speaking, because then you can compare it side by side. But here we go. It's already finished. It ran very quickly because there's only 20 rows in our eval set, so very small just for testing. But we can click it, takes us to it, and we can see that it passed every single thing. So we got a 100% accuracy. So 20 passed, 0 failed, and 20 were graded successfully. Very cool, right? So that's our evaluation done. So now what you would want to do at this point is, first of all, come up with a better data set. Like I said, this is only 20 rows. So you want to have something bigger, more representative of the production data that the model will be seeing so you can evaluate it accurately. But also, if it wasn't 100%, if it's, I don't know, 40, 60%, now we can do different things like tweaking the prompt or tweaking the model. So to do that, you click add run. So we're creating a new run based on our existing evaluation that we've set up, and we can choose the data. So we're going to choose the same exact data. We can give it a name if we want to. Then we have the prompt. So if you want to change the prompt, this is where you can do it. So you can then run the evaluation based on that prompt. And then I'm going to change the model. So I'm going to leave the prompt the same because it's a very simple prompt, but I'm going to change the model. So we're going to change it from GPT-5 to their earlier models like GPT-3.5 Turbo. So this is their dumbest model pretty much, since they have so many advanced models now. So if you run this, I want to see the comparison, okay? So everything looks good, same data, same prompt, same input, variable, different model. Let's see how it compares. Run it. Okay, so it's queued, it's gonna run in a second. There we go, it finished. We can see that with a dumber model, an older model got 95%, which is still really good, but obviously there's a difference, right? Because the model is not as capable. So it says 19 out of 20 passed. Let's click into it so we can see that only this one failed. So the presentation was average, nothing memorable. It's supposed to be neutral, but it output a negative, so that's a fail. And you can switch between runs, that's nice. You can also export the data if you want to. If you want to store it somewhere, give it to somebody. Now, also, if you've ever done machine learning before, you're never just going to take the accuracy at face value, right? This is only 20 rows, so this is good enough. But if you have a larger eval or test set with a different distribution of positive and negative samples and also neutral, the accuracy will not be representative of the quality of the model, okay? So what I mean to say is that if you're trying to be rigorous in your testing, and if you have experience with testing models, what you can then do is you can export this evaluation run here, or you can pull it down programmatically, and then you can calculate things like the F1 score, the precision, and the recall, stuff like that, that you would normally calculate for machine learning models that you create yourself. In this case, we're not creating it ourselves, we're just evaluating a pre-created model, but you still want to have an accurate set of metrics for that, okay? So if you're not too experienced with the machine learning, then don't worry about that. This is still a good, a decent representation of how the model does, but if you're familiar with what I'm talking about when I say F1 precision recall, that's what you would want to do at this point, okay? So hopefully that makes sense. Okay, so now that you have a feel for how to create and run evaluations on the UI on the website, now let's go through how to do it programmatically. So the first thing that I'm going to do is go back to the documentation. I just want to show this again, emphasize that it's very important because it's just good, you need to follow this rather than just following my video. So this tells you how to create it programmatically. You can also follow this as a reference besides my video. And then also very important is go to up here to API reference. These are the actual like API docs. So using the Python API, there's other APIs, but the Python API is what we're going to be using. It tells you for evals all the different things that you can do and how to do it. So for create eval, it tells you what it does. It gives you a code example of how to actually do it. Sometimes the examples aren't the best and there's not many of them. So the documentation is a little bit limited in that respect, but it's still very helpful if you get stuck to come here and see what can actually be passed into these, things here, okay? So this shows you how to create evals, run them, get them, create runs from them, all kinds of stuff that I'll be showing you in this episode in just a second. But come here if you need help, okay? First things first, I'm going to switch the task that we're doing just to give you a unique example as we do this programmatically. So on Hugging Face, this is a website, if you don't know, where you can find all kinds of stuff for training machine learning models, such as datasets, the models themselves, and other resources. This is a dataset here for multiple choice medical questions. So I think this is going to be a good use case to do evaluations based on because it can be kind of tricky versus sentiment analysis. So just taking a look at the data here, the first column is the question itself. So for example, this first one says a woman presents to the ER after a 2-week upper respiratory system infection, gives some more details, blah, blah, blah. What is typical to find in the physical examination? So it gives you 2 options per question. Option A is systolic click, and option B is neck vein congestion. So question, option A, option B. The answer is neck vein congestion, and it also gives you the answer ID, which is B. So you can use either one. So if we want to run evaluations on this dataset to see how models perform on it, what we want to do is take the dataset here and put it as a JSON-L or a CSV file, because that's what evaluations expect. So we're going to use JSON-L because it's the more popular format. And we need two things in that dataset, right? Generally speaking, we need what the model is going to be given, so the input of the model, and then the expected output. And in terms of what the model will be given every sample, we'll give them the question, but then they also need the options that are available because the model has to choose which one. So we're going to craft a new column out of these three columns here where we're going to have the question followed by A, and then the name here says to click, and then B, and then the name of that value. And then we're going to tell the model in the prompt to choose A or B. So it'll literally output the letters A or B, and then we're going to check that against the answer index column, okay? So what I've done is I made a local script that will just take the data set from Hugging Face, download it, and do all that pre-processing, and then save it to a JSON-L file. This is what it looks like. We have two columns, the message, which is, like I told you, the combination of the question, and then at the end here it says new line, option A, new line, option B, and then the answer, the expected answer is A for this one. So it's going to do that for every single sample. And that's going to be an object, right? An object with those two fields. And one thing that's a little weird when you do it programmatically versus through the UI is that every sample for a JSON-L file needs to be surrounded with this item object. So instead of just having message and answer as each entry, you're going to surround it with this item. It's what they use in their examples as well in the documentation. So you can see that instead of just ticket text and correct label as a single object, they surround it with the item field object thingamajiggy. And I tried doing it without that because it does allow you to do it without it on the UI. You can just upload it like before with it by itself like that. But I spent like 2 hours on it, and for some reason when you do it programmatically, it doesn't work without it. So you have to surround it. I think it's because when you do it through the UI, it automatically wraps it with item, but when you do it programmatically, it doesn't. So either way, it does have to be wrapped, it seems. But since we're doing it via code, we have to do it ourselves, okay? So I really hope that makes sense. It's just a small thing that you need to make sure that you do. That's what they do in their examples, so we'll do it as well. So message, answer, surrounded with item, and that's our data set, okay? So this is before what we would upload when we're creating our evaluation. I've got a notebook here. This is what I'm going to be using to run the code. For this to work, make sure that you have the OpenAI Python package installed. So just install that. And now what we're going to do is create a client. This is just following the documentation. Use OpenAI, create a new OpenAI client. This is what we'll be using to interact with their API programmatically. You can provide an API key like this as a parameter. We're just extracting it from our environmental variables. Or you can use Python load environment to load it into your thingamajiggy, automatically load it. But I'm just doing it explicitly here. So yeah, in my .env file, I have a environmental variable called OpenAI API key, and it's set to my API key. So if you don't have an API key, just go to your account and go ahead and make one. It's really easy. Now, just to make sure everything's working, let's run this. And then now what we're going to do is let's just invoke one of the models now to make sure it's working, make sure that we can actually use the model before we create an evaluation. So let's do response is equal to client.responses.create. We're using the OpenAI responses API to send it a message. So we're going to specify the model. We're going to use GPT-5. Then we're going to provide an input to this. So we'll say, what's up, homie? And then we'll just print out the output text. So let's run it. Hopefully it works. Let's see. There we go. Hey, what's good? How can I help you today? Need info, ideas, or just want to chat about something? So now that we know we can hit the model, we should be good. That means we have money on our account and everything's set up successfully. So an evaluation is made up of two things. First, we have the actual data schema. So this will define the schema of the data for the evaluation and also define what data is available to the run of the evaluation when we're evaluating it. So define the data schema. And then number two is the testing criteria. So like, checking by a string or other criteria. So we're going to define those two things by doing eval is equal to client.eval to access the Evals API. Great. First, we got the name of our eval. So we'll say, let's say medical question eval. Next, we want the data source config. This is the configuration of that data schema that I told you about. Coming here to the docs, it says that the data source config is the configuration for the data source used for evaluation runs. It dictates the schema of the data used in the evaluation. And so there's different types. One of them is deprecated. And the one that we're going to be using is the custom data source configuration. So this defines a custom schema for any data that we want to go into our evaluation. They also support this other format for logs, so you can run it based on logs, it seems. Never use that, but it's an option if you want it. So you can expand this further, see what it expects. So a custom data source config accepts a item schema, so simply the form of the data in JSON, the type of the data, and then whether we should include sample data. What's also great, just to help you out, because this can be a little confusing, the examples aren't always the best, you can go to one of your evaluations, and what's really cool is that if you go down here to the bottom right, it gives you the schema for this evaluation that you've already created through the UI. So we can actually just borrow that. So we're going to copy that whole object, and before we paste it, we want to define first the type. So the type is going to be custom, and then now we're going to define the item schema, and we can paste that object that we just copied. We just need to fix the formatting. Okay, this should be good. So this is defining the input data schema. So this is not matching what we want to do. So we just need to change it to match what we're trying to do. So if we go here to medical questions, the JSON-L file that we'll be using, we just got to look at it. So we'll see that we have two fields, message, and the other one is called answer_IDX. So in our notebook, we're going to specify those as properties. So first one is message, the type is a string, and then the next one is answer_IDX, and the type is a string. So these are the two fields of the input data. And then you also have this required here. This is just specifying what's required. So we're going to require both. Because technically the input data set can have multiple fields, but maybe you just don't want all of them as required. So you can have that, or you can just put all of them there. And it's as simple as that. So now we have defined the schema for the eval set. The next thing is this other field here. This is optional. We can specify include sample schema. We're going to set this to true. We did this in the UI before so that when we're setting up the testing criteria, we can use the variables that represent the output of the model. This will give us access to the same thing. So this will give us access to our input data. This also includes fields for the output of the model. All right, that's it for the data source config. Now we can specify part 2, which is our testing criteria, how the evaluation will be tested. So coming back here to the API reference, we have testing criteria. And these 5 types here represent the 5 types that I showed you in the UI. So it's one-to-one, corresponds to one another. So anything you can do through the UI, you can also do here. All right, so I'm going to do testing criteria. And this is going to be a list because we can have multiple. So we're going to set up a new object. And this is going to be of the type string check, because we're just trying to check that the output string, the answer A or B, is equal to what it expects. We can set up a name for it. So we can say whatever we want. So checks output matches. It's probably a horrible name, but there we go. The operation that we're trying to do is just equals. It's trying to see if the output is equal to the expected output. And then now we have input, and then we have reference. So the input should be what the model produced. So we can do, because we set this to true here, we can now do sample dot output text. And then here we can do another variable. This is what the model should produce from our data set. So to access a field from our schema here, we can do item dot, and then the field name is answer IDX. Boom. So now this testing criteria here will check to see if the sample output text is equal to the expected field here. So I think, as you can see, if you understand how we did it through the UI, it's not too hard via code. So we have defined our eval. So let's go ahead and run it and see if it comes back successfully. Here we go. So eval create response, we get this response and we get a bunch of data back, like the created date, the ID, that's very important. You want to copy the ID, and then you just get a confirmation essentially of all the information of the evaluation. And now we want to create a run off of the evaluation, which is actually running the model on it, right? Before we do that though, look up here, right? We define the schema of the data, but the run is where we actually upload the data, okay? So we need to upload the data, and there's 2 ways we can do it. So we can go through the UI and upload a file there and then get the ID for that and use it in our code. Or what we can do is upload the file programmatically. So I'll show you how to do that. So we'll do file is equal to client.files create. We're going to specify the file that we're trying to upload. So we're going to use open, and then our file name is just medical questions. And then we can also tag it with a purpose evals. Okay, so that will upload the file and should give us, it's questions plural. All right, let's run it now. There we go, we get our file ID. So we'll copy this, and then now let's move this down below. And now we're going to create the run. So we'll do run is equal to client.evals.runs.create. We're going to specify our eval ID. And now we want to specify something called the data source. And if we go back to our evaluations, we go here, we can see these different runs that we have, and we can actually click this and view data source. The data source is how we're invoking the run. So what model we're using, the configuration of the model, like the temperature and stuff like that, the prompt that we'll be using, the developer message, and then how we're going to be sending it the user message. So when we did it through the UI, we set that all up. That is the data source of the run. And then everything above that, this is the actual data that we're going to feed the run. This is going to be replaced with the file ID that we uploaded. So right here, it's hard coded, but this will be dynamically populated with the file contents, okay? So for this particular one, it's using the responses API to do a run based on that. So you can copy this entire thing if you wanted to, and then replace the file content with the file that we just uploaded, and you can run it based on that. Or you can use, a lot of the examples use the older completions API, so that one's perfectly valid as well. So we'll come here, we'll do create eval run, and then data source. This is where it says we have JSON-L, completions run data source, and responses run data source. We'll be using the completions data source, but yeah, you can also use responses if you want to. I'm going to go back to Docs here and just copy the example that they provided because it's easier than typing it all out in front of you. And here we go. So we got completions for the type, how we're invoking the model. The model itself, we can use whatever you want. I'll use GPT-5. We have our input messages. So first we have our developer message, which is our prompt. Let's replace this entire thing with our actual prompt. We're simply going to say, given the following question and options, respond with only A or B. And then the user message, this is going to be what we feed the model. So this needs to be replaced with our actual user message field. So if we go back up to our data schema, we have message and answer. So let's use message, item.message. Now down here we have the source. This is where the data is actually coming from. So we can replace this with our file ID. Nice. And that's it. We're simply providing the data for the run. And then we're saying for each sample of that data, we're going to invoke the model using the completions API with a GPT-5 and give it a developer message with the prompt and then a user message with the actual input data, run it and get a response. So let's go ahead and run it, see what happens. Okay, cool. It looks good to me. So we get a run create response. We get a run ID that we'll copy. And basically the way it works is this takes time, right? This is not something that responds instantaneously. So the way it works realistically is you get the run ID and then you pull it. So you basically get it over and over until it completes. So it'll give you a status every time you hit it. And once it completes, you'll know it's done. Then you can get the output, the result of it. We can also do run.reports URL. This is really cool. It gives you a link that you can just directly use to go to it. So we can see it's already finished here. We can click into it, see how it did. It got 100%. So every question that we fed it, it gave us the proper answer, which is awesome. That's actually really surprising because that means GPT-5 is really good at these medical questions here. So maybe, I'm not a doctor obviously, so I don't know how hard these are, but it's still pretty impressive. These seem pretty tough. So that's how you can retrieve it through the UI. You can also retrieve it programmatically. So client.evals.runs.retrieve. So we're going to retrieve it through the eval ID and then the run ID. We'll say run.id. There we go. So now if I run this, it gives us the run response, but it's kind of a lot, right? So you want to just look at the API to see what data you can extract from this. One of these is the run.result counts. So this gives us a summary of the results. So we see 0 of them errored, 0 failed, and 41 passed. So there was 41 total and they all passed. So using this, you can then calculate the accuracy. It's 100% obviously in this case. And I believe there's a status as well. Let me see. Yeah, there's a status. So let's do another run. So let's replace GPT-5 with 3.5 Turbo. Let's see if it's as good at these medical questions here. So let's run it. Boom. And then we're going to run this. So it's queued. Just keep watching it. In progress, so it's running now. And it's completed. So now we can go ahead and change it to result counts. So obviously, realistically, you would set up like a loop or something that checks over and over until it's completed or fails. Now we get 25 failed, 16 passed, 41 total. So you can see that GPT-5 seems to be really smart and good at this task, but an older model like GPT 3.5 is not as smart. So this is what evaluations are all about. We can compare models and prompts. So potentially with a better prompt, maybe we can get a better outcome from this, but this is more based on the knowledge of the model. So I don't really think a different prompt would help as much. This is just the knowledge of the model overall. But in different situations, different prompts would definitely affect the outcome. Pretty freaking cool, right? We can also do get eval run output items. This returns the actual outputs of the run itself. So every sample of the data set, how it was fed through the model, the actual output from the model. And then based on that, you can then calculate other stuff like F1 score, precision, recall, and stuff like that. So you can get all of this data. You can see it's in this format here. So very, very useful if you want to look into that. Okay, guys, that's it. That's all I'm going to show you about the OpenAI evaluations framework. Now you guys should hopefully be able to run evaluations for whatever you're trying to use OpenAI models for to figure out how they're performing in your software that you're working on. So I really hope you guys enjoyed the video and you learned a lot. Of course, there's a lot more I could show, like different testing criteria and stuff like that, but my hope is that this was enough to get on the ground running. All of the code for this entire video will be in the description below, so you could check it out and work with it yourself if you want to replicate what I was doing or see examples. And yeah, if you enjoyed the video, then please leave a like, please subscribe if you want to see more. Let me know what you guys want to see. I will be happy to look into and make a video on it. This was actually a suggestion by someone else, so I really appreciate that suggestion. So yeah, leave a comment below, like, subscribe, appreciate the support, and peace.